Hi, Dahlia Remler here again, and we're going to talk about sampling now. Sampling is about how you select the people, organizations, the cases that you're going to use for your study. And mostly we're going to focus on the idea of trying to get a representative sample. That is to say, a sample that will represent a population, some group we want to describe. A lot of these ideas will also apply to qualitative research. Qualitative researchers talk about selecting cases. Before we hone in on sampling, I want to talk about generalizability, which we've discussed before. And that's about how when you do a study, which is in a particular context, place, time, setting, etc., how much you can learn about other settings. So this is obviously key. You know, you're never going to have exactly the same time, place, context, etc. You'd like to learn something. So if you're a principal of a high school and a study is done at a particular high school or particular high schools in particular times and places, and they learn that some kind of program is effective, or they learn that students have particular types of barriers to success, you want to know if that generalizes to your situation. So obviously that's incredibly important, and especially important to practitioners as consumers of research. Generalizability is also known as external validity. You've already seen for measurement there are a whole bunch of validities. We're going to have even more of them. So in general, if you have a choice, I prefer the term generalizability. We're still in the description part of the textbook, where we're just trying to say what is out there in the world. But in the second half, we'll talk about causal studies, where you're trying to learn what works, the effects of programs. And it turns out that experiments to look at causation are more generalizable than you would expect from that kind of setting. It also turns out that even descriptive relationships are more generalizable than a lot of just averages and prevalences. So generalizing beyond the population of a study is a little bit more of an art or a craft than a science, not as technical as like the random sampling or the complex survey sampling we're going to get. You really have to think about it, and we'll be practicing a lot. But right now, why don't you pause a second, think about that opening study about the post-Katrina evacuees staying in the Red Cross shelter in Austin, Texas. Think about what they learned. Think about, hey, there are a bunch of hurricanes going on now. If I was an emergency response administrator, to what extent do I think what we learned in that study would generalize to now? Okay, so back to sampling itself. So this is a kind of diagram you may have seen in statistics. There's some population, and you're going to sample. You're going to take a subset. You'll have a sample. You'll do various statistics, averages, proportions, correlations, maybe if you're interested in relationship, or crosstabs. And you're going to take those results in your sample and infer that it's telling you about the population. And in stats, you learned about, needing enough data, a big enough sample to get precise enough estimates to learn about your population. And we'll talk some more about that. But I also want to just emphasize a couple of things that are very important in population research. One is be clear about the definition of the population. What population are you studying? Are you studying all U.S. high school students, U.S. high school students in public schools? Are you studying, high school students of particular types of high schools? And as we'll be learning, there's also the population you want to study, your ideal one, and the one you actually do get to study. And that's even before we talk about some sampling problems. So once you have thought about your population and you've thought about the sample you're going to get, you need to think about how representative the sample is of the population. So some basic sampling concepts. As you probably know, some studies don't have any sample. You want to get everyone. This is referred to as census, like the census, the 2020 census that is going on right now, that happens every 10 years and that occurs in many countries. That's not the only census. You could try and look at all the actively practicing cosmetic surgeons in North America. The student evaluations that you get at the end of each semester, that's a census too. We ask every single student to give us evaluations. You probably know everyone doesn't respond though. Please do, by the way. It's still a census because we try to get everyone. Even though we didn't fail, that's going to be a non-response problem that we're going to talk about shortly. So how do you actually select a sample? The first key is to get a sampling frame. What does that mean? That's an incredibly important piece of jargon for sampling. It's ideally a list of the entire population. So, for example, we have an email list of all of the MPA and MIA and Masters of Higher Ed students at the Mark School. That is a great sampling frame. It's a list of emails. Every single student has an email. Pretty much all organizations have this now, and it's why it's pretty easy to do a survey of an organization. Well, again, we have that response rate problem. There are lots of sampling frames of the list, but unfortunately, there often aren't sampling frames, there aren't lists of the population that we want to describe. So how do we get the people or, the elements of the population that we want? And a common one is all people exiting a poll, not existing, exiting. Sorry about that. That has been very, very important. In this election, we'll talk about why that's a little more complicated, but the idea is suppose we want to sample everybody who votes. Well, we don't have a list of everybody who votes on the day of the election, but we basically speak with everybody who leaves the polling place. So what are the basic steps in sampling? First, you define the population first. Who do we want? Do we want voters? Do we want master's students at our school? Who do we want to study? Then we need a frame. Often you don't have a frame that's a list, and so you need some other way of operationalizing that representation. So one is people exiting places they vote. It could be exiting a school building, for example. It can be a strategy for calling telephone numbers, strategy for reaching out on the internet. Once we have some way of representing the population, we select a subset of units to be in the sample, or we don't. We do a census and take everyone. Then you have to contact the sampled people. Sometimes it's organizations and not people. but then you need to find a representative, and you ask their participation. You hope they participate, record responses or observe them, summarize findings, and draw conclusions about the population. So, a problem that we have, so there are a lot of problems with actually getting the people we need to make our sample representative of the population. And one kind is called a coverage problem. So think about that example I was just giving in the sampling frame being people who leave the polling places. So you could say, oh, we're going to describe the population of voters, but all the people who leave all the polling places. Well, what's happening this year? Lots of people don't want to vote in person. That's always true that there are people who don't vote in person, but we're expecting a lot more mailing and voting. Also often they do this by asking people on election day, what about early voting? If you do that kind of exit polling, you have a problem where your sampling frame, people leaving the polling places, doesn't match the population you want of every voter. So here's an example of the idea of population and sampling mismatch. In that red, we have the whole population. The green is the sampling frame. This place, the in population but not in sampling frame, that's like all the people who vote mail-in or absentee and or who vote early. They're not leaving the polling places on election day. In that example, we don't have a problem of people who are in the sampling frame but not in the population. But think about a lot of telephone surveys. Telephone surveys often work by randomly calling people with an area code indicating that they live in a place to vote in the particular election. Well, we all know now with cell phones and everyone taking their phone number when they move, that we have a lot of people who will be in that sampling frame, but they're not in the population. That can be overcoverage. So now these kinds of problems, these coverage problems where the sampling frame doesn't match the population, may or may not result in coverage bias. So you have a problem where, hey, we're missing out on these people, but that may or may not result in bias. We'll be spending more time on this, but basically it causes bias when the sampling frame and population are related to what you want to measure. Another kind of problem, which I'm sure you've all been thinking about, is our non-response problem. Many of us don't answer our phones if it's a number we don't know. There are big problems with response rates on surveys. Maybe you don't contact people, people don't answer their phone, or they don't open their email message. And even if you do reach them, they may not cooperate. Contact and cooperation together affect response. So the rate, you can see that even if you've got a fantastic 50% contact rate, which isn't very standard now, and then say you have a fantastic 70% cooperation rate, that's still a 35% response rate. For many, many types of general population surveys like election polling, it's much, much smaller than that now. But happily, these election polls don't turn out to be completely nonsense just because, they only reach 2% of the people, because it's often not biased. Non-response only causes bias when that propensity to respond is it related to what you want to measure. So in the book, we have this example of about a poll from recycling, and we did have an example of why you might have bias in that case. So this is another case of where we're going to use the path diagrams, and we're going to use them to try and understand non-response bias and coverage bias in surveys. So in that, there'll always be the variable you want to measure somewhere. In that case, it was recycling and how likely people were to recycle. And then we have another variable for the likelihood of them responding to the poll. And we were concerned that, hey, people who do recycle are more likely to respond to the poll. Hi, we're taking a poll about recycling. Can I get you started? People who are not into recycling. Oh, God, I don't want to hear about this again. I don't want people guilt tripping me. No. But if someone who's really enthusiastic, yes. Another way of looking at the same idea here is here is the variable we want to measure. How often do you recycle? Here's the propensity to respond, and here's commitment to the environment. More commitment to the environment, more causes, note the direction that arrow causes, being more likely to recycle. More commitment to the environment, yes, I do want to respond and help you in your survey. What does that mean? In both this one or the other analysis, there's a relationship between being likely, the propensity to respond, and how often you recycle. What does that do? It means that the pool of respondents is disproportionately recyclers. Recyclers are overrepresented. Non-recyclers are underrepresented, and that causes bias. The number you get from, recycle often is too high. It's higher than reality. It's upward biased. But again, luckily, since response rates are really low now, not all non-response problems result in bias. Luckily, not all non-response problems cause bias. Think about doing a job satisfaction survey at a particular workplace. People need to be at the workplace to respond, but some people are going to be home with the flu. Well, if they're home with the flu, they're not going to respond. So being homesick with the flu makes them less likely to respond. But if being homesick with the flu is unrelated to job satisfaction, it won't cause any bias. We won't have people who are more satisfied with their jobs disproportionately reported, or people less satisfied. So this non-response problem won't cause bias. So what are the steps in assessing coverage bias? Same for non-response bias, same ideas. You're basically looking for systematic differences. So for coverage bias, identify the sampling frame, who is in the sampling frame but not in the target. Same for non-response, who didn't respond that is in your population. Assess systematic differences, determine whether the propensity to be covered is related in any way to what the study is measuring, and if so, how, and then describe the bias. What happens when you don't have a very good sampling frame because the actual population is really unknown, maybe even to people themselves? So think about wanting to do polling, like election polling, in a period like we're in now, before people have even voted and nobody knows who is going to vote. To make these predictions, election pollsters use something called likely voter models because they don't have the actual voters. Even the people themselves don't have the actual voters. This table shows how sensitive the results can be to those models. So this is from the New York Times Upshot polling in the 2018 Texas Senate race. And they did a really useful exercise. They had their own poll, so they had all the data, they had everyone who they reached, that they used calling cell phones and landline phones. They had that, they had the characteristics, and they had what people said to answer a wide variety of questions, and they had to decide what to do with that data. So they have their own model, their estimate, and in their estimate, they predicted that there would be 6.3 million voters in the Texas Senate race, and that Ted Cruz would be ahead of Beto O'Rourke. Ted Cruz is a Republican in red, O'Rourke is the Democrat in blue, by 8 percentage points. This was a very unusual election for political reasons. Some of you may measure. And O'Rourke was getting a lot of attention. A lot of people are like, I'm going to vote, I'm going to turn out. So here's another way of looking at it. People who say they are almost certain to vote boosted turnout by a whole million people. And in that, O'Rourke led by 3 points. Wow, what a difference how you model who's going to turn out. They tried some others. They had a model people whose voting history suggests they will vote regardless of what they say about whether they can vote. Cruz 0.9. People who say they will vote adjusted for past levels of truthfulness. Cruz +8. Every active registered voter. Cruz +4. Kinds of people who voted in 2014. Not a presidential election like 2018. Oh my gosh, Cruz +15. People who voted in 2016, the last presidential election, Cruz +5. You can see the problem here. The population that we want to describe, actual voters, doesn't have a list, and in many ways, it's not determined yet. So you can see how sensitive that is. Okay, so that's it for part 1 of sampling, where we focused on the big picture general ideas. The portion of generalizability that's related to sampling, which is the representativeness, although as we emphasize, that's not all of generalizability, and also about coverage and non-response problems and the bias they can have. I want you to understand that while election polling and traditional surveys are important aspects of this, sampling is much wider. Like, you can sample from material things like air quality. You can sample from data from websites out there on the internet. So this idea of sampling is much broader, and in a major theme of this course, really is something to think hard about when you see those data analytics. See you in part 2.